All right, well, welcome back for Lab 4. So, as you know, we did the bones of the distal humerus on down. So, from distal humerus down through the radius, the ulna, all the carpal bones, metacarpals, phalanges, etc. last time. So, now we got to put muscles on those. The good news is a couple of those repeat. The bad news is only a couple of those repeat. So, we got quite a few muscles to run through this time. But as you can see, the very first one is a repeater from the shoulder. So if you look at Lab 4, if you've got the sheet in front of you, the first table says muscles of the elbow complex. So the elbow complex is going to include 3 joints, and those are from Lab 3 that we talked about last time. But the 3 joints, remember that the primary hinge joint of the elbow is the humero-ulnar joint. And then you've also got the humero-radial joint, and at both of those two, humero-ulnar and humero-radial, you have flexion and extension are the 2 actions that occur there. Then the other joint in the elbow complex is the radio-ulnar joint. So at the radio-ulnar joint is where you've got pronation and supination. So you flip the forearm over or back and forth at the radio-ulnar joint. And remember, that's both proximal and distal radio-ulnar joints, because there's one up by the elbow and then there's one down by the wrist, as we'll talk about here in a minute. So the first muscle, again, is one that you've seen before. So we got biceps brachii, currently highlighting the short head, but there's the long head right there. So in terms of the origin, insertion, and action of biceps brachii, so remember that biceps has 2 origins. So with the short head, that one's going to originate from the coracoid process. The long head there originates from just above the glenoid, so the supraglenoid tubercle. Both of those two run together. You have a common belly and a common tendon of insertion into the tuberosity of the radius. So previously we talked about biceps as a flexor at the glenohumeral joint. Biceps is also a flexor at the humero-ulnar joint, and then it's a supinator as well. So biceps is additionally a supinator at the radial-ulnar joints. So biceps then is actually a triarticular muscle. It crosses 3 joints. So it's a flexor, glenohumeral, and then a flexor, humero-ulnar, and then a supinator, radial-ulnar. So biceps does quite a few things. And so because of that, biceps is one of the more commonly injured muscles in the upper arm. Next one is our brachialis. So brachialis, you can see the origin there is the anterior surface of the lower half of the humerus. So pretty big origin there. And if you look at the skeletons in the lab, there'll be a big red splotch on their anterior humerus. That's going to be the origin. And then the insertion, as we talked about in lab last week, is into both the coronoid process of the ulna as well as the tuberosity of the ulna. So it kind of crosses both. So because brachialis only inserts into the ulna, it can't have any effect on supination or pronation. So all brachialis does is flexion at the humero-ulnar joint. So elbow flexion, effectively. So humero-ulnar flexion is its action. And then one of the things I would point out about it is that because of its insertion onto the ulna, and because it has no effect on supination and pronation, no matter how your forearm is positioned, brachialis is equally strong in all positions, as opposed to biceps is able to exert more force in elbow flexion if your palms are supinated. But brachialis, it doesn't really matter. And then we get to the last of our primary elbow flexors, which is brachioradialis. So brachioradialis is one where the position does matter in terms of its strength. But regarding origin and insertion, the origin of brachioradialis is that lateral supracondylar ridge. So technically the upper 2/3 of the lateral supracondylar ridge. And then the insertion is way down here. Remember we talked about the radial styloid last time. So it's going to insert into the styloid of the radius. And so brachioradialis is an elbow flexor, and it's strongest in a neutral position, so thumbs up kind of a position. That's when brachioradialis is going to exert the most force. So if you do things like hammer curls, that's where you're going to favor brachioradialis. But in addition to it being a flexor at the humero-ulnar joint, it's also both a supinator and a pronator at the radial-ulnar joints as well. So our 3 primary elbow flexors then, biceps brachii, brachialis, and brachioradialis. Then we move on to Pronator Terry's. So Pronator Terry's is on the medial aspect of the elbow. It's one of the muscles. So remember one of the things we talked about in lab was the medial epicondyle, being the site of origin for the wrist flexor and pronator group, called that because of Pronator Terry. So you can see Pronator Terry's there. So it tells you what it does, obviously. It's a pronator. And in terms of origin and insertion, so again, the origin is there on the medial epicondyle of the humerus, and the insertion is about halfway down on the lateral shaft of the radius. So if it's going to cause pronation, supination, it has to insert onto the radius, and Pronator Terry's inserts about halfway down, effectively the midpoint of the shaft of the radius. And so then when it shortens, it's going to cause pronation. Then we have the other pronator. So you can see from the picture there that we had to strip off quite a few layers of muscle. So Pronator Quadratus is a fairly deep muscle. So it's underneath some of those wrist flexors and finger flexors that we're going to talk about in a minute. So it's the deepest layer. And you can also see it's a fairly small muscle, right? So the name comes from the shape, four-sided muscle. So Pronator Quadratus originates on the ulna, specifically on the distal quarter of the ulna, and it's going to insert onto the distal quarter of the radius, both on the anterior aspect. And so when that little muscle shortens, it's going to pull the radius closer to the ulna and effectively flip the radius over the top of the ulna. So it is a pronator at the radio-ulnar joints, both proximal and distal. Then we go to our triceps. So highlighted here is just the long head, but remember that triceps means 3 heads. So triceps has 3 heads. So the long head that we've already talked about originates at the infraglenoid tubercle. So go to the glenoid and then go just below that, which is infraglenoid. So it originates from the infraglenoid tubercle. And then you've got the posterolateral humerus, which is for the lateral head here. And then you've got the posteromedial humerus for the medial head there. So you got 3 heads. You got a long head, lateral head, medial head. All 3 of those run together and they have a common tendon of insertion. So you can see all of this is the tendinous insertion, which gives it that characteristic horseshoe shape that we would associate with a well-developed triceps. So all 3 heads come together, common tendon of insertion into the olecranon. So then at the elbow, triceps is going to be a humeral-ulnar extensor. So extension at the humeral-ulnar joint. And then as we talked about last time, it's a biarticular muscle, so it is also an extensor at the glenohumeral joint as well. So an extensor at 2 joints, biarticular muscle. Then we're moving over to the lateral epicondyle. So remember, the lateral epicondyle is the origin of the wrist extensor supinator group, so named because of supinator. And you can see supinator highlighted there. It's a deeper muscle, so you'll have to take off some of the more superficial muscles in order to see it on the plastic arm in lab. But you can see the origin there, the lateral epicondyle of the humerus, and then the insertion is into the lateral aspect of the proximal third of the radius. So it has a pretty big insertion, basically the closest third of the radius there. In terms of its action, tells you what it does. It's a supinator. So you've got 2 primary supinators at the radio-ulnar joints then. You've got biceps brachii, which is the strongest one, and then you also have supinator. In terms of pronators, both of them have pronator in the name, so there's Pronator Terry and Pronator Quadratus. And then the last muscle on the first table is the Anconeus, and Anconeus, as you can see there, is a pretty small little muscle. So Anconeus is another one that originates on the lateral epicondyle, inserts on the proximal aspect, so more specifically the lateral aspect of the upper quarter of the ulna, and Anconeus is going to be a fairly weak humeral-ulnar extensor. So it's an elbow extensor. It works with triceps. Those are your 2 primary elbow extensors. But as you would imagine, just based on the size of their bellies, triceps is a much more powerful humeral-ulnar extensor than what we see with Anconeus. And then that is the entire first chart there. So then we'll move on to, so all of those then elbow complex muscles. So now we'll move on to the wrist joint. Remember that the wrist joint, the anatomical name for it is the radiocarpal joint, because it's the interaction between the distal aspect of the radius and then the scaphoid and lunate, which are 2 of your carpal bones. So all the rest of these are going to be at least radiocarpal muscles, but some of them will also have some effect on the fingers, so they may cause flexion or extension at the metacarpophalangeal joints or flexion extension at the interphalangeal joints. So We're going to start on the lateral aspect of the forearm. So this one is right next to, and by this one I mean Extensor Carpi Radialis Longus, is right next to Brachioradialis. So Brachioradialis is here, and I'll show you how to find these in lab. But what you can do is basically resist elbow flexion with your thumb up, and Brachioradialis will pop right up. And then if you extend the wrist, you'll be able to palpate or feel Extensor Carpi Radialis Longus and Brevis right next to it. So the origin of Extensor Carpi Radialis Longus is the lateral epicondyle. So the good thing is, I'm about to save you some time on writing on the next several, because most of them, actually all of the next few, originate on the lateral epicondyle. And you can see the insertion if we follow the tendon all the way down of Extensor Carpi Radialis Longus. It's going to insert on the base of the second metacarpal. So the second metacarpal being the long bone of the hand that's associated with your index finger. So it is going to cause both radiocarpal extension, so it's a wrist extensor. But in addition to that, it's going to cause radial deviation. So it's going to bring the thumb side of your hand closer to your forearm, and that is also a radiocarpal motion. So two radiocarpal motions for Extensor Carpi Radialis Longus, radiocarpal extension, and then radial deviation. Then we've got Extensor Carpi Radialis Brevis. So if something is brevis, it's a little bit shorter. So the reason for the longus and brevis, longus originates a little bit higher up, a little more proximally on the lateral epicondyle than brevis does, so it's a slightly longer muscle. So that's where the name difference comes from. So Extensor Carpi Radialis Brevis also originates from the lateral epicondyle, again just slightly more distally. And then it's going to insert on the base of the third metacarpal, so you can follow its little tendon down here. So again, that is the one that's associated with the third finger, so your middle finger. And we say the base of the metacarpal, so the proximal aspect of the metacarpals are their bases, and then the distal aspect down here where I'm mousing over, those are the heads. So both of these last two insert on the bases of metacarpals 2 and 3 respectively. Extensor Carpi Radialis Brevis is an extensor at the radiocarpal joint, so it's a wrist extensor. But one of the things you'll notice is that because of its insertion on the middle finger, basically, so on the third metacarpal, its origin and insertion are essentially right near the midline of the posterior aspect of the forearm, so it's only going to be a radiocarpal or wrist extensor. It's not going to have any effect on radial or ulnar deviation. So only a wrist extensor, which is a radiocarpal extensor. Then we move on to Extensor Digitorum. So you can see Extensor Digitorum has one big belly here, and then the tendon actually splits into 4. So one aspect of the tendon goes to your second finger, third, fourth, and fifth, respectively. So in terms of origin insertion, Extensor Digitorum originates, like the last two, at the lateral epicondyle. But in terms of insertion, so it's going to insert on the base of each phalanx of digits 2 through 5. So it's going to insert, there's my mouse, so on the base of each phalanx. So again, here, the metacarpals are here, and then you've got the proximal phalanx here, middle or intermediate phalanx here, and then distal phalanx here. So it inserts on the base of the proximal phalanx there, and then middle phalanx there, and then distal phalanx there. So as a result of it spanning the radiocarpal joint, so the wrist joint, as well as the metacarpophalangeal, and then PIP and DIP joints, Extensor Digitorum is going to do a lot. So it is a radiocarpal or wrist extensor. It's also a metacarpophalangeal extensor of digits 2 through 5. So again, your pointer finger out to your pinky. And then at the PIP joints of the same, and then DIP joints of the same. So it's going to cause extension at all of those things. So in terms of actions, extensor radiocarpal, or extensor MCP 2 through 5, or extensor IP 2 through 5. So any of those would be correct. Fairly large muscle as far as the forearm goes. It is a fairly obvious muscle too. If you look at the backside or the posterior aspect of your wrist and you kind of fan your fingers a little bit, you'll be able to see it contracting. So it's a pretty obvious little muscle. All right, and then this one you could almost miss. This is my favorite muscle. So this is Extensor Digiti Minimi. So it's this tiny little muscle here, even highlighted, it's almost hard to see. So Extensor Digiti Minimi is basically an offshoot of Extensor Digitorum, but it's generally considered a separate muscle. So it also rises from the lateral epicondyle. Just like Extensor Digitorum, it's going to insert into the base of the proximal phalanx, and then dorsal expansion we'll skip over for now, but it's going to insert into the base of the proximal phalanx of the fifth digit, which is your pinky. So Extensor Digiti Minimi tells you what it does. It extends your minimum digit, which means that it extends your pinky. But it also crosses the radiocarpal joint, so then it is going to be a radiocarpal or wrist extensor as well. So the actions for digiti minimi, Extensor Digiti Minimi, are radiocarpal extension, metacarpophalangeal or MCP extension on the fifth finger, and then PIP and DIP extension. So you can see there's a term on there, I skipped over it for a second, which is the dorsal expansion. You can't see it all that well on this picture, but on some of the other diagrams you'll see there's kind of like a little diamond shape on the back of the IP joints, so here. So that's the dorsal expansion. And so the tendon kind of makes a little diamond shape, and then one part runs right through the middle to insert on the base of the next bone, or on the base of the next phalanx. So that's Extensor Digiti Minimi. Then we've got Extensor Carpi Ulnaris, which is highlighted for you there. So this is the last of the muscles that originates at the lateral epicondyle. So the origin, again, lateral epicondyle, insertion, base of the fifth metacarpal. So it's not going to have any effect on the finger, on the fifth finger, because it's going to insert on the metacarpal. So it's pretty similar to Extensor Carpi Radialis Longus, which I'm mousing over the insertion there, Extensor Carpi Radialis Brevis. So pretty similar to those two, except this one inserts onto the base of the fifth metacarpal. So in terms of action then, it's going to be a radiocarpal extensor, so wrist extensor. And since it inserts more on the medial aspect of the forearm, if we're in anatomical position, it is also an ulnar deviator. So radiocarpal or wrist extension, and then ulnar deviation are its actions. So then the lateral epicondyle muscles, you've got everything from Extensor Carpi Radialis Longus, Extensor Carpi Radialis Brevis, Extensor Digitorum, Extensor Digiti Minimi, and then the last one is this one, which is Extensor Carpi Ulnaris. So now we're going to go a little bit deeper. So we're going to strip off some of these superficial layers of muscle and go a little bit deeper. And so you can see Extensor Indicis here. So indicis sounds a lot like index finger, which is good because that's what it does. It tells you what it does. Extensor Indicis extends your index finger. And you can see the origin there. So the lower third of the ulna and the interosseous membrane, which is what we talked about in class with the syndesmotic type joints. So from the ulna as well as the interosseous membrane. And so the insertion there is the base of the proximal phalanx and dorsal expansion that we just talked about of the second finger. So the dorsal expansion is what's going to extend the PIP and DIP joints. So Extensor Indicis then is a relatively weak radiocarpal or wrist extensor, and then it's also an extensor of the MCP and both IP joints of the second digit, which again is your index finger. And again, it's a deeper muscle, so it's underneath Extensor Digitorum. So if you're trying to find it on the anatomy app, got to take off a layer of muscle. All right, so now we're flipping sides. We're going to the anterior aspect of the forearm, and we're going to some of those medial epicondyle muscles. So we already covered Pronator Terry, which is here. So now we're going to go with the wrist flexor group. So the wrist flexor group, the first one there, if we're working lateral to medial, is our Flexor Carpi Radialis. So again, the origin for all of the next three muscles is going to be the medial epicondyle. In terms of the insertion of Flexor Carpi Radialis, it's going to insert on the base of the second metacarpal. So just take Extensor Carpi Radialis Longus on the other side and flip it. So we're going to insert on the base of the second metacarpal, and so it's going to be a radiocarpal flexor and then a radial deviator as well. Then we got our palmaris longus. So again, moving lateral to medial. So there's palmaris longus. Again, origins medial epicondyle. The insertion is the palmar aponeurosis, which is this white stuff that's highlighted here. So it's connective tissue on the palmar aspect of your hand. And then in terms of action, because it's located right along the midline, it is only a radiocarpal or wrist flexor. No effect on ulnar or radial deviation. Then we got our Flexor Carpi Ulnaris. More on the ulnar aspect. So you can see I kind of had to rotate the model a little bit, so I had to rotate him so I could see more of the medial aspect of the elbow. But that is your flexor carpi ulnaris. Again, origin is the medial epicondyle, and then the insertion is actually into the pisiform, but also into the fifth metacarpal. So this is the one when we found pisiform and then slid it left and right, and I mentioned that pisiform is a sesamoid bone. It's a bone in a tendon. This is the tendon where the pisiform resides, which is flexor carpi ulnaris. So in terms of actions, radiocarpal flexor, and then it's also an ulnar deviator. So one of the things that you've probably noticed then is that in order to do radial deviation, you need an extensor and a flexor. So specifically, to do radial deviation, you need the action of extensor carpi radialis longus and then flexor carpi radialis. Those two combine to do radial deviation. And same concept on the ulnar side. So if you take extensor carpi ulnaris, flexor carpi ulnaris, their action together, that'll produce ulnar deviation. We're going to see something really similar when we talk about the hamstrings as well. All right, so those are my medial epicondyle muscles for the most part, but now we're going to go a little bit deeper. So now we're going to go with Flexor Digitorum superficialis. So Flexor Digitorum superficialis is the more superficial of the two finger flexor muscles that we're about to talk about. Excuse me, so the origin is the common flexor tendon from the medial epicondyle. And then the important part is the insertion into the middle phalanx, there we go, into the middle phalanx of digits 2 through 5. So in terms of actions then, it's going to be a radiocarpal or wrist flexor, and then a flexor at the MCP joints, and then because it inserts on the middle phalanx, it's going to flex the proximal interphalangeal joint of digits 2 through 5, but that's it. So it stops there, so it can't have any effect on the DIP joints. So that's the action, or those are the actions of Flexor Digitorum superficialis. So radiocarpal, wrist flexion, metacarpophalangeal flexion on digits 2 through 5, and then flexion of the PIP joints of digits 2 through 5 as well. And if we take off superficialis, so we go to a deeper layer of muscle, then we can see Flexor Digitorum profundus. So profundus originates from the proximal 2/3 of the ulna, as well as the interosseous membrane, but importantly, Flexor Digitorum profundus inserts all the way down on the distal phalanx of digits 2 through 5. So it has all the same actions of Flexor Digitorum superficialis, except that because it inserts more distally into that distal phalanx, it is also a flexor at the DIP joints of digits 2 through 5. So it's a flexor radiocarpal, but also a flexor metacarpophalangeal, PIP, and DIP. So Flexor Digitorum profundus does quite a bit, fairly active muscle. Then we have our Extensor Pollicis longus. So anytime we're talking about pollics or pollicis, that's going to deal with the thumb. So Extensor Pollicis tells you that it extends the thumb. So remember we talked about the anatomical snuff box and how you could find scaphoid in it. So the two tendons there, you had Extensor Pollicis longus right here, and then Brevis is this one right here, which we'll talk about here in a second. So Extensor Pollicis longus originates from the posterior aspect of the ulna, as you can see. So essentially the middle third, and then also partially on the interosseous membrane. So it's going to insert all the way down on the distal phalanx, because remember the thumb only has two, so there's a proximal phalanx and a distal phalanx. And so Extensor Pollicis longus is going to insert on the distal phalanx of the first digit. So it's going to cause thumb extension. So it'll extend at both the metacarpophalangeal joint. Well, I shouldn't say both, at all three. So at the metacarpophalangeal joint, but also the IP joint and at the carpometacarpal joint, which is back here. So remember, that's the joint between the trapezium and the first metacarpal, that long bone of the hand right here. So it'll cause extension at all three of those joints. So carpometacarpal, metacarpophalangeal, and then IP joint as well. Then we're going to go with Extensor Pollicis brevis. So the origin there, you can see it's a shorter muscle. Again, brevis is a short or relatively short muscle. So the origin is the distal third of the radius rather than the ulna. So distal third of the radius, and then the proximal phalanx rather than the distal phalanx of the first finger. So Extensor Pollicis brevis then is going to be an extensor only at 2 of those 3 joints. So only at the carpometacarpal and the metacarpophalangeal joints. So it's an extensor at 2 of the 3 joints that pollicis longus is active at. Then we got our abductor muscle. So this little guy so the previous 2, Extensor Pollicis longus and Brevis, those 2 form the anatomical snuff box, and you can see your little scaphoid in here. And then and then the abductor runs right along the tendon of Brevis, and you can actually separate those 2. I'll show you how to do it if you're interested in doing it. But those 2 run pretty close together, and they are, like I said, you can separate them. So abductor pollicis longus, the origin is the upper third of the ulna, as well as the interosseous membrane, and then the middle third of the radius as well. So fairly large origin for abductor pollicis longus. Inserts onto the base of the first metacarpal, and its action is abduction at the carpometacarpal joint. So remember, that's kind of that weird looking position where from anatomical position you move your thumb straight forward or straight anteriorly. Remember that that's what abduction of the thumb looks like, and that occurs at the carpometacarpal joint. So only one more to go, and that's on the anterior aspect. So that's our Flexor Pollicis longus. So guess what it does? It's a flexor. The origin there, the middle third of the radius, as well as the interosseous membrane. The insertion all the way down on the distal phalanx. So then Flexor Pollicis longus is a flexor of the thumb at the carpometacarpal joint, metacarpophalangeal joint, and IP joint of the thumb. It's also an assister in flexion of the wrist, so the radiocarpal joint. So Flexor Pollicis longus is a wrist flexor, so radiocarpal flexor, as well as carpometacarpal, metacarpophalangeal, and the IP joint of the thumb. All right, so those are all of our muscles that we're going to cover. So all the muscles that we covered are what are referred to as extrinsic muscles, which means that they originate in the forearm and then they insert somewhere in the hand. That's as opposed to intrinsic muscles, like this muscle, that is responsible for abducting your 5th finger. So the intrinsic muscles, like this one, so they originate and insert in the hand. So the good news is we're not going to cover any of these little guys. We're just going to cover the extrinsic muscles, which are the ones that we already did. So we'll see you in lab this week and go over and try to find all of these little guys on the plastic arms.